Hey, I'm Matthias Shapiro, Technical Evangelist at Microsoft, and this is Inside Windows Phone. Today we're going to talk about MVVM. This is the architecture, the structure that we use to make most Windows Phone projects run. It's kind of baked into our project templates, and it's how we make good, solid architectured Windows Phone projects. Now, the basic structure of MVVM we're going to talk about in a minute, but the first thing we need to keep in mind is when to use MVVM. A lot of people think that MVVM is the thing we use all the time, every time. But if you're building a very small application, like a one-page or two-page application, it might make more sense just to do things like kind of a ad hoc way of building your application, where you take your XAML and you put your XAML in your project and you do some manual hitting some services, hooking up some events, and pushing information onto your UI, onto your page, just manually. That's perfectly fine if we're building small applications. But where MVVM really comes in handy is when we start building those larger applications, where we have several different pages, a lot of data structures we need to manage. And so for the rest of this video, we're going to talk about how we do it. So starting off, what is MVVM? What does it stand for? Well, it stands for Model, View, View Model. So Model, View, View Model. And the idea here is that with models represent the data objects that we're using in our applications. We'll be using a demo for Twitter, so in that situation, the model that we have is going to be a tweet. What does a tweet have? It's got a bunch of properties for when was this tweet made, and what was the name of the person that made it, and were they replying to someone, and what's the text of the tweet, and what's the avatar. All this information is going to be in the model. The model is considered to be kind of a dumb object. It doesn't have a lot of business logic in it. It just kind of sits there and we can read it in our application, do stuff to it. The view is where we end up seeing all this information. In most, in C# especially, Windows Phone applications, the view is going to be a bunch of XAML, and we'll have some text boxes and some buttons, and all of these items are going to represent the UI representation of the models or the data that we have inside our application. So, model, view, and lastly, view model. This is like the real meat of our application. It's where we fire off the services in order to start getting representations of our model, getting our data back. When our view and our UI starts to do something, it's going to send a message out to the view model, and the view model is going to be the place where it really does the work. It's going to handle all of the threading, all of the calls and the callbacks, the events. The bulk of our application lives inside of our view model. So how do these different pieces interact? Well, the view model is going to usually hold pieces of the model or representations of the model called properties. And it communicates those properties to our view using something called data binding. If you go back in 2 episodes in Inside Windows Phone, you'll see a whole session on data binding where we talk about iNotify property changed and how it's really kind of this magical secret sauce where the view model can update the view without a lot of complex code interacting. It simply updates a property, and the view can see that update. And so that's how data binding communicates between the view model and the view. But if the user is interacting with the UI, and the UI needs to tell our view model, our business logic, what exactly is going on, then we'll use something called commands. The commands are something, it's a property that we can bind inside of our view. And it sends information, it sends a notification out to the view model and says, hey, I want you to run this piece of code. We're going to look at that in a little more depth in a moment. And then lastly, another way that we can communicate is between the view model and the view is using events and messages. Events, hopefully we're all familiar with. We create an event inside of our view model, usually. And then when we fire off that event, we have maybe an element inside of our view code behind, or maybe another view model that's listening to that event, and we can communicate that way. Messages is a similar concept where we fire off a message, and the message goes into a message queue, and the message queue looks for some piece of code that's listening for that message. And if it hears that message, it'll run a piece of code, and we can manage our application that way. So what benefits, what do we get out of this? One thing we get is a question that I come across frequently is, okay, so we've got our views, we've got our view models. Is that a one-to-one relationship? Do I need a view model for every view that I have? And the answer is no. if you build your view models appropriately, you can actually build multiple views on top of your view model. Let's take a look at an application where we do exactly that. Okay, this is an application. This is a Twitter sample from the Microsoft sample applications that are online. You can get this, download most of this off MSDN. I've made a couple little tweaks. Uh-oh. Oh. Looks like I've, my last minute stuff has come back to bite me. Okay, we're going to try it again. I've made a couple little tweaks, but this is basically an example of using a long list selector and dynamic loading to create an infinite scrolling example. So if I look up something like Channel 9 in this application, I get a bunch of tweets that are Channel 9 related. Now, unfortunately, Channel 9 isn't the only Channel 9, so we don't always just get awesome Channel 9 content when we search for it. But we do get all of these elements in here. And what we've done is when I hit the Enter button on inside this text box, it's bound to a command. And the command takes that and says, oh, okay, I see this is an update from the view and you want me to go get something. But the thing that we're really looking at here is how one view model can drive multiple views. So this is one view. And if we look back in our application, we'll see that this is actually the main view. It's the view that we load when we load up. But if we want to look at details of this tweet, we can tap on one of the tweets. And this takes us to an entirely new view. This is a view that I've called Tweet Detail. And you can see I've done a little bit of different design to it, not particularly elegant or anything. But the point is that we've got two views here that are being driven by the same view model. Now, how is that possible? Let's take a little bit of a deeper look at the code that's driving this. So when we load up the tweets, we push the tweets into this thing called Twitter collection. And inside of our main page.xaml, you've got our design view over here. But you can see we have our long list selector. Give myself a little more space here. And the source is bound to that Twitter collection, observable collection. So that's great. Okay, that's how we get to see all of the tweets in there. And then when we want to update more items in that list, all we have to do is add more items to the Twitter collection. That's a little bit of the data binding MVVM magic in action. But what about tweet detail? How do we make our tweet detail work the way we want it to work? Well, inside of our view model, we have an item called selected tweet. And what happens is whenever we select a tweet using our long list selector, it goes and it says, okay, this particular Twitter search result item is the selected tweet. And so all we have to do, once we've identified that particular tweet as our selected tweet, all we have to do is navigate to our tweet detail page and say, okay, inside of this grid, and maybe this might be easier to look at inside of Blend. So inside of this grid that holds all of the information for our tweet, we're just going to set the data context to be that selected tweet. Let me zoom in a little bit here. It's just that selected tweet. It's just we want the entire context of this grid to be that property inside of our view model. And so once we've done that, we can do the navigation. We don't need to spin up separate view models for every view we have. We can run multiple view models off of a single view. This is particularly awesome, as I said, for those master detail views that we have in place, where we can load the data, preload the data. We don't have to reload the data. We don't have to transfer data from one view model to another other view model. We can actually build our detail page using just a subset of the data that we gained from our original view model. So let's take just a step back here. And another one of the questions that I get a lot when I'm talking about MVVM is, what is the right way to do MVVM? And when I was learning how to do MVVM, my biggest frustration was that people would come in, they would say, there is no right way to do MVVM. There's this library, there's that library, and do it any way you want to. Well, that wasn't really great guidance for me. I don't want to do it any way I want to. I want you to tell me some way to do this. And what I found was that once I found that specific guidance, I could expand on it. And now my answer is, of course, do it any way you want to. But I'll show you the basics of how to get started. So we've got our view model. We've got our view model here. I've got a sample view model, and I've got a Twitter view model. The Twitter view model is what I'm running the application on. So how do I make this visible to my XAML file? Well, what I'm going to do is, there's a couple of different ways to do it, but this is the way that I find is the most helpful, in part because it's kind of baked in to some of the samples that, some of the templates that we have that are MVVM templates in Windows Phone. Here inside of my app.xaml.cs, this is kind of a global namespace. And so if we go in here, what I go and do is I go in here and I create this sort of singleton concept of I've got a Twitter view model as a private static object, and then a public static object. And whenever that public static object gets called, I simply take a look at my private object. I say, okay, does it exist? If it doesn't exist, create it and then return it. So now anytime I use the code app.twittervm, I will either get back the existing view model or it'll create a new one. And so that's what we end up doing inside of my main page.xaml, is that when I start the page just the first time, I have this code here. I set my data context to be that app.twittervm. And that way I have instant access. I've set the context. And another pattern that you're going to see a lot is this concept of inside of my view code behind, I'll have Twitter view model, and I'll simply return my data context as that object. And so that way, within my code behind, I can simply say, okay, view model dot. I can run commands, and I can get properties. I can run methods if that's how I want to structure my project. And so then, when I move this main page, we'll remember is that's my master page with a list of all the tweets. If I want to get access to that Twitter VM inside of my detail page, I go to my Twitter detail.xaml.cs, and I do the same thing. This.data context app.twittervm, and this sets it so that all the XAML can see all the properties, all the public properties that I have, and all of my commands, everything that I need that's built inside of that Twitter view model. So that's to me the easiest way to get started if you're building MVVM. So we've looked at using view models. We've looked at using view models across multiple pages in a master detail scenario. Let's look at some of the key pieces that makes this possible. The first one is the concept of data binding. And the idea of data binding is simply this. My view model implements this concept of iNotifyPropertyChanged. When it does that, it needs to implement these items here. Property changed event handler, and then a private method notify property changed. And this sets it up so that we can do data binding, so that when I go into my XAML, I can do things like set my item source to bind to a property inside of my view model. So when how do I create a new property, a new thing that I can bind to? I do so with this model here, or this concept here. The idea that we have a property, a private property, and then a public getter, except that every time we set the property, we fire off notify property changed with the name of the property that we want changed. And so this is what ties data binding together. Again, if you want to look deeper into data binding, which is really the kind of the magic glue that ties everything together, 2 episodes back in Inside Windows Phone, we go over it in great more detail. But the other piece of data binding, or of MVVM, that really makes it work is the concept of commands. The beauty of commands, let's not go back there. But the beauty of commands is they implement an item, a concept called iCommand. So let's open up a command and take a look at this. This is a delegate command, and it was pulled from a Windows Phone Geeks blog, and I'll give the URL for that at the end of this video. But the basic concept of an iCommand is that it has an execute parameter and it has a can execute property. And so the execute is what we fire when we want the command to run. And so we can bind that as a property to the command. We can either bind it to a command property on, for example, a button that we have. We have a button that has a command property, and we can say command equals binding whatever my command name is. And then whenever the user presses that button, it'll fire off the code that's associated with that command. And that would be fine. I mean, normally maybe we would our normal way of doing things is we'd shoot off a method when we did that. So why would we want to use commanding over methods? Well, the reason is because when we bind to that command, it's also going to start looking at this. It's going to start looking at can execute. And can execute is valuable because we don't have to build any sort of, is this service running? Am I doing an update? Because when we do execute, we can put code in there that says, okay, when this command executes, if it's hitting a service, while that service is running, set the can execute to false. Because if this can execute is set to false, all of a sudden our button is smart enough to know, oh, wait a second, I'm going to switch myself from being able to execute. The disabled state of our button switches from off to on. And so that means the user isn't going to hit the button several times. They hit the button